My name is Carl Schlemmer, and I work for the Mastry Engine Center. Tech support. Been doing that for a little over 40 years. This is Doug Dykins over here. He's in charge of service in our warranty department, and he's been doing that for almost as long as I have. So we have some experience in maintenance, obviously, and troubleshooting, and we take, over the course of days, we take a lot of phone calls from a lot of different individuals about a lot of different subjects. So we have, pretty good knowledge of the kind of things kind of questions that people ask, and so it gives us, a little insight as to what we really need to talk about, what people need to know. These are some of the subjects we're going to cover here. Pre-start inspection, operation, shutdown, maintenance, boat maintenance, and excessive smoke. So you want to start with a pre-start inspection, and that's important because you get familiar with the way things are supposed to look. And if something doesn't look the same from one day to the next, that's going to alert you as to what, maybe you need to investigate that a little bit more. So you're looking for oil leakage, water leakage, fuel leakage, any kind of loose parts, damaged parts. You want to keep a clean bilge. You don't want to have oil, fuel, whatever residue down there, because then you're not going to know if it's something new or something old. So it's very important to start with a clean bilge, especially if you see like a bolt laying in the bilge or a piece of a hose clamp or something you don't recognize that wasn't there the day before. That's going to, lead you into looking further to investigate as to where this piece of whatever it is may have come from. So that's very important. Plus, the color of what you see in the bilge is going to happen, kind of steer you in the right direction, whether it's darker like engine oil or more different color like antifreeze or possibly oil. But it's not dark, so maybe it's transmission fluid, that kind of a thing. So just get familiar with it and keep an eye out for that. I know this sounds basic here. Fluid levels, obviously. Tank valves, are they open? Not only your fuel valves on your tank, but if you have a boat that has multiple fuel tanks, make sure the switching valves are in the correct positions, because we get phone calls from people that have, fuel-related issues, and they think it may be a problem with the engine. Well, come to find out, it's actually, them or their partner, whoever, was down there switching fuel tanks, and they actually found they had the fuel switching valves in the incorrect positions, causing a problem with the engine. So, very important that the fuel valves were in the correct positions. Raw water strainer, seacock, is it open? Some people shut the seacock off illegally for a period of time, sometimes they don't. You may want to put a tag on at your helm, remove before flight like an airplane, make sure your seacock is open. Your raw water strainer, when you look at your strainer, you'd be surprised how many times I talk to people that have cooling system issues with their engine, and it can all be traced back to the seawater strainer, allowing debris to get into the engine to create issues with the engine. If you're looking at your strainer and you remove the top and the strainer basket itself, the handle is cracked or broken or missing, that's an indication that somebody at some point in time probably did not install that strainer back into the strainer housing correctly. So when you go to put the lid back on, the first thing it does is it breaks the handle off and cracks it. So that's a good indication that at some point that engine was not having the water strained properly to it. So keep that in mind. Engine alarms. Turn on the ignition and listen for your alarms. If you've got a mechanically injected engine, the audible alarm may continue to sound until the engine starts. If you have an electronically controlled engine, the alarm may sound just for a moment as a test or a check to let you know that the alarm is functioning, and then it turns off until the engine starts. Turn on the ignition, look for your alarms. Oil pressure gauges should zero out. Coolant temperature gauges should read approximately ambient temp. Very important. That applies for mechanically controlled engines as well as electronically controlled engines. Ignition on, engine not running, that oil pressure gauge should be sitting at 0. If that oil pressure gauge is sitting at 10 pounds or 20 pounds or something like that, then it's going to be inaccurate when that engine starts. It's going to go way higher than it normally should, typically. So that's a very simple check you can do at the beginning of the day. Just quick scan your gauges. Make sure that the gauges are zeroed out or reading ambient temperature. Whether you've got an LCD window that just has a number, or you have like an analog type gauge that has a needle on it. Either applies for both. Have a look at your exhaust system. Do you see any darkness around any of these areas where the exhaust elbow meets the engine, or any point in between the muffler clamps? You see any broken or damaged clamps? I go to a boat occasionally, and I see a lot of darkness around the exhaust connections, and I ask, how long has this been going on? Well, it's always been like that. Well, it's not good. There should be no darkness of any kind around any of these joints, because what happens is that engine is a giant vacuum cleaner, and it's going to inhale all of that, or a majority of that exhaust, certain fumes and what have you. And it will cause problems with the engine. If you have a turbocharged engine especially, it can clog up the intercooler for the turbocharger. So if you see any potential exhaust leaks, address them as soon as possible. Do not let that continue. This is one where the engine is below the waterline or at the waterline. This would be what they would call a lift type exhaust system. Typical on many sailboats, a lot of catamarans, big power cats that use this similar system. It's a big power cat is typically like 2 sailboats put together. This device right here, does anybody recognize this device here? What that is? That would be mandatory on an application where the engine is, the water line is in this relationship to the engine. It's going to be a siphon brake, anti-siphon brake, that keeps the seawater from flowing back into your exhaust system and eventually backing up to the engine. So a lot of people, almost every sailboat has this for sure. Like I say, some power boats have it. Sometimes you'll have that on your generator. Sometimes your generator will have a siphon brake if your main engines don't. So that just be aware that that is a maintenance item, and if your boat has it, you need to know where it is, because a lot of times the boat builders do a pretty good job of hiding that thing and making it very difficult to get to. If you have one, be aware of where it is and check it periodically, and depending on which brand you have, because there are several different types and they function in different ways, but they all serve the same purpose. So get familiar with the manufacturer, maker of the type that you have, and test it according to their instructions periodically. Make sure it's functioning properly, because it can cause catastrophic failure to your engine if that device fails. So it's very important that it's functioning properly. Operation. Annual usage, I say, they think of is somewhere around 250 hours. Some people put less, some people put more. Continuous operation is around 90% of the rated horsepower, so 90% power. You have a maximum power rating on your engine, and you have a continuous power rating on your engine. The continuous power rating would be where you would normally operate it, would be like your max cruise RPM, basically, is what that would be. The max rating would be your wide open throttle rating, and that would be, you should be able to attain that number at an absolute minimum on your maximum loaded conditions or above. It's typically above. So a continuous wide open would be normally not more than 30 minutes in an 8-hour period. Cool down. 1,000 RPMs or less for 5 minutes. Suddenly stopping the engine after running it at or near full power can have detrimental effects to the engine and to the oil. And also this applies to your generator. So don't simply go over to your generator and just shut that thing down after you've been running 3 air conditioners and everything else. Give that generator a cool down period of maybe 5 minutes after you take the load off of it. Let it cool down, and it's going to be a lot happier when you shut it off the next time you start it. Be familiar with your owner's manual. I can't stress this enough. I can't tell you how many times the guy comes to our parts counter, or we get a phone call asking for technical advice on a certain problem that they have, and the guy on the other end of the phone isn't really sure about what engine he has. So whether you're asking for technical advice, or you're buying parts, or you're talking to a dealer about coming to your boat to service your boat for some reason, it's absolutely critical that you know your engine model, your transmission model, and your serial number, because it's bad information in, bad information out. You order parts that are incorrect. The technician comes to your boat to service your engine, and he's got the wrong parts, and he can't do it, and he's got to come back. So, absolutely critical. Don't refer to your engine as a horsepower. Okay, refer to it as the specific engine model and serial number if you're asked for, because some parts do require the serial number to get the correct parts. Also, your owner's manual has a lot of good information on it, some more than others, depending on the engine model, how old it is. They have troubleshooting information in there. They have information about fuses. Where are my fuses located? If you have an electronic engine, they'll have information in there about the control system, about trouble codes, what the different trouble codes mean, an explanation of the trouble codes, things like that. They give maintenance in there. They'll give 50-hour, 150, 250, whatever, and they'll give a brief description about what's required, the different points on the engine that require maintenance and all that. So a lot of the phone calls that I get and that Doug gets and our other tech support people get can be answered by simply looking at your operator's manual, and a lot of those answers to those questions are in there. If you're going to do service, get the proper tools. The engines do not require a lot of the things that you're going to be doing for maintenance do not require a lot of specialized tools, basic hand tools, but just have a set of dedicated tools to do the maintenance, and you're going to be using, you'll find that there's just a few wrenches or a few sockets or whatever the case that you're going to be using over and over again. So just make sure that you have the correct tools. Don't try to do it with pliers or something. You get sockets and wrenches and whatever tools are required to do the maintenance that you perform. The operator's manual will call it out, and like I said, they'll say initial 50 hours. Now this is mostly targeted in Yanmar, but other engine manufacturers are similar. They talk about draining the fuel tank. Well, unless you got a commercial boat, you're probably not going to be draining your fuel tank. There's not a provision for that. So drain. Look at your water separators and your primary fuel filters, and if there's water in there, drain it out. But one thing I want to mention: if there's water in there, that's not normal. There should be no water. So if you're seeing water in there on a regular basis, find out why. Do you have a deck fill that's missing an O-ring? Do you have a vent that's taking water in? Are you getting water from the actual supplier that supplies the fuel to you, or where you buy your fuel? But if you're seeing water in there, that's not normal and that's not good. So you need to figure out why that is, because it can create all kinds of issues with your fuel and ultimately issues with your engine. Oil, the typical oil that we use mostly in our engines is 1540, the CI4 Yanmar. Yanmar has their own brand of oil. Antifreeze, 50-50 premix, absolutely do not my opinion, do not use antifreeze that you have to mix with water. I've had all kinds of horror stories told to me about people that do that, because if you mix it the wrong ratio or don't mix it, you can absolutely create problems with your entropy problems. So always use the pre-mixed coolant. Ours is red, red or orange, extended life, long life coolant. And they typically tell you, you can check your engine model, but typically around 2 years is when they say
If you want to add, if they don't know what type of coolant you have and you need to top it off, just put distilled water in it. Not tap water, but distilled water. You don't want to start mixing coolants, and you don't want to start using chlorinated water. Just go to the store, get a gallon of distilled water, and then, you know, of course, we want to find out at some point too why it's down. The level is down, but, you know, just add distilled water if you need to.
Checking belt tension, if you see a lot of black or belt dust around your belts, most likely they're probably loose, or you're having a lot of heavy duty load, a lot of charging load, and that's going to also add to the belt dust that you may see. But if you got like a V-belt, older style belt, typically there's going to be a quarter, like a half-inch plate when you push on the belt. If you were to grab the alternator, the pulley on the alternator and the fan, you shouldn't be able to turn that. If you can turn that with your hand, the belt's too loose, or the belt is worn out. So you should not be able to turn the pulley with your hand. If you've got what they call a multi-groove belt, or like some people refer to it as a serpentine belt, those can be a little trickier. Some of them have automatic tensioners on them, which is great, and you don't have to do anything. If you don't have an automatic tensioner on it, then typically those belts, you don't really push on them like you do a V-belt. You rotate a quarter of a turn. If you can go 90 degrees from flat, and that's about all the farther you can turn it, then that's pretty good. You can do a push test, but the turning test is a little better. If you can turn it more than a quarter of a turn, this probably needs to be tightened a little bit. So those can be a little bit trickery when you're tightening, because they don't have as much stretch in them as a regular V-belt does. Intake and exhaust valve clearance, really recommend a dealer do that if it needs to be done. Some people get into doing it by themselves, but it's usually best if you have a dealer do that type of a thing. Shaft alignment is, I get calls about that periodically. About shaft alignment, typically is done with the boat in the water. And with feeler gauges, and normally you're talking about the gap between the output shaft of the transmission and your prop shaft flange. You would remove the bolts and hold one flange still and rotate the other flange a quarter of a turn and check the gap, and the gap should stay constant. It shouldn't change. If the gap changes with the rotation of the shaft, then you either got a bent coupling or a bent flange. If the shaft, if that gap stays the same, then it's just, and it's excessive, and it's just out of alignment, and it needs to be aligned. The manual will tell you change the filters. Some manuals may say 250. Especially where this really becomes tricky is on your fuel filters. And I've gone to people's boats before and think they have an engine problem. What they really have is a fuel filter issue. And I look at the filters, and they're really, not good. They're dirty. And they'll say, they'll get their book out and they go, well, wait a minute, my book says don't replace it until 250 hours. Well, that's all depending on the conditions of your fuel. So, if you've got really contaminated fuel, you may need to change your filters in 50 hours, not 250 hours. These are recommendations. Your particular situation may be different, so adjust the schedule accordingly. On engine filters, some of them have water sensors in them. So if water were to make it past your primary fuel filter and get to your engine-mounted fuel filter, it'll set an alarm off at your helm. So if you're getting that, you want to shut that engine off as soon as possible. And if you don't change the filter, at least get the water out, because water is really detrimental to your fuel system, and you want to get that out as soon as possible. Some of the primary fuel filter elements, the housings will have a water sensor in them as well, so that'll alert you long before the water actually gets to your engine. So that's a good thing as well. So if you get that alarm, make sure you stop at your earliest convenience. Or if you've got like a dual filter setup, you can switch over to the other filter until you get time to get the water out. But don't let it continue if you get an alarm. Investigate the situation and see how it's progressing.
There's something on the fuel too. If you don't use currently any type of a biocide or fuel treatment, we highly recommend it. Don't wait till you have a problem and then start treating the fuel. You're chasing your tail at that point. You'll never get it right. Even with fuel polishing, it just never seems to get it right. You're constantly going to battle it. So if you're not using some sort of a fuel biocide, please start using it. Don't wait.
As far as primary fuel filters, we get questions a lot of times, what primary fuel filter micron rating should I use? Some manufacturers will have several micron ratings, a 2 micron, a 10 micron, or a 30 micron. What you want is two-stage filtering. Some people try to use a 2 micron, which is the smallest particle, on their primary filter, and they think, okay, if I'm doing this, in their mind, they don't have to change their engine filters often because this primary filter is catching all this. That's not really a good way to approach it. Your fuel is your lifeblood of your fuel system. It not only makes your engine run, but it lubricates and cools your fuel injection system. So if you start restricting it for fuel, you're really doing a disservice to your fuel system. It's gonna not live as long and not be as happy. So we really recommend a two-stage, and that would be like a 30 micron primary, and then your engine mounted filter is going to be, you don't have an option there. It's whatever the engine manufacturer says is required for that engine. So there's only one available on the engine, and use the original equipment filter. Don't try to experiment because it can be very costly if you do. Mechanically injected engines in the past, you always hear people talking about bleeding the fuel system. Well, yes, there's bleed points on them. You can bleed the engine-mounted fuel filter. You can view, and in some cases, you can bleed the fuel injection system, the fuel injection pump. You can even bleed the injection lines at the injectors. And that's all well and good, and you got to be careful, about doing that. Obviously, if fuel leaks. And you don't want to come in contact with any kind of high pressure fuel and that sort of thing. So there's cautions in the manual that need to be followed on doing that. But some have automatic bleeding devices, and that's not required at all, even on a mechanically injected engine. But when it comes to an electronically controlled engine, referred to like a common rail engine, I sometimes get questions about people asking me, well, how do I bleed that? Do I bleed it like my old engine? And the answer to that question is absolutely not. You do not, under any circumstance, open any of the fuel injection lines on a common rail engine. There's no bleeding like there is on a mechanically injected engine. So they technically tell you, if you go around and you start loosening fuel injection lines, high pressure injection lines on your common rail fuel injected engine, every one of those lines that you just loosened, they want you to replace. So if you loosened it, replace it. So, and like I say, it's just not necessary, they're self-bleeding. So the only bleed points on a common rail engine would be the secondary fuel filter, or the fuel filter that's actually mounted to the engine. So don't try to loosen any injection lines or high pressure lines on a common rail engine. Seawater pump impeller, I get a lot of questions about that. Gee, I have a hard time getting to it, I have a hard time changing it. But I can tell you, you need to inspect it periodically, because you can see from this picture, there's these little screws around the outside of this housing. And if you don't periodically take those little screws out and remove the cover and look at the impeller, chances are you're not going to be able to get them out when you need to. If you go down there with a wrench and you go to loosen it, you do have an issue with the impeller, and the first thing you do is you break the bolt off in the housing. So it's very important that you periodically inspect that like the manual tells you. If you don't have one, I highly recommend you get one. They are a lifesaver, a game changer when it comes to replacing impellers. A lot of people will use the one-hit wonder tools that we referred to earlier in this presentation. They'll end up damaging the pump. So if you do get the impeller out and you put a new one in, now your brand new impeller is damaged because you just damaged the housing that the impeller turns in. So I highly recommend this type of, pay attention to this impeller when you put it in. Make sure if your impeller has threads on it, that they're facing you, so you can use this tool. And I'm telling you, even if you have an impeller that's in a difficult place to get to, people say, gee, I can hardly see the thing, or I can't see it. If you practice with this a little bit, I guarantee you can use this tool with your eyes closed. You can do it blind. It's that easy to use. Other types of impellers you see, impeller pullers, they look similar to this, where it's got arms on it and a push screw or a jacking screw. Those are not easy to use. Some of the impeller manufacturers that actually sell these things, I see them, in the market. But and what the problem with these things is, a lot of times you can't. These are physically so large you can't get them in there. The other tool is smaller than the impeller, so it fits in there. If the impeller fits in there, the tool's going to fit. Not so with this tool. It's not as easy to use. Air intake. Silencer cleaning elements. Some air intake filters are cleanable, some are not. Some are just foam. If you see it starting to deteriorate, just replace it, put a new one on. Where this is especially important, cleaning, is if you have some of them are aftermarket filters, some are came with the engine. Would be like an air set type filter, where it's more of a filter that needs to be cleaned. They sell cleaning kits for them. You can clean them if you feel so inclined. A lot of people don't want to take the time to clean them, and they just replace them anyway. But that type of a filter would need to be cleaned or replaced. It's more important because it can actually restrict the air intake to your engine and cause performance problems if it's not maintained properly. And especially if you have an exhaust leak like I talked about earlier, that accelerates that. Where you would normally clean that at maybe 200 hours, now you need to clean it at 20 hours after you've had an exhaust leak, because it's going to clog up your air filter for sure. Top 3 causes of poor performance and smoke. Fouled hull bottom, running gear. I can't tell you how many times I get phone calls from people that have what they think is a performance issue with their engine, and it really turns out to be a fouled hull bottom or running gear. It's absolutely critical that you keep that clean for the proper performance of the engine. You don't overload the engine. Can't overstress that enough, especially in the high growth months and the summer months. You got to double up on your cleaning, because it just gets fouled that much quicker, especially if you're close to needing a bottom job, or the paint's coming off your props. Very important. Second cause. Fouled hull bottom. Right. That's the second most cause of that condition. Or like I said, air filters can also cause that, depending on the type, and especially if you've had an exhaust leak, can greatly accelerate that situation. And the third most cause, so can't overstress that enough. Keep it clean. Has a huge effect on the performance of your boat, fuel economy, and everything else. The range on your boat diminishes when your bottom is not clean, so it's very important. Like I say, it depends on the environment, where the boat's operated, the time of year, the paint longevity. You get stuff that looks like this. it can be very deceiving because, I don't know if you can tell from this picture, you probably can't, but if you look at the bottom panel of the boat or on the outside, and man, it looks great. It looks really good. And then you pull the boat out of the water and it looks like this. You know, so the paint is like completely gone, and you've got this lot of growth, especially even like seawater intakes, depending on whether you've got a colander type intake or a scoop type intake or a screen like this type. The barnacles can accumulate not only on the outside of this, but on the inside of it. Cause of poor performance and leading cause of low stored on the engine. Clogged fuel filters, clogged fuel pickups, switching valves, clogged fuel switching valves. Once again, clogged fuel filters, pickups, switching valves. Fuel that many times we find air leaks in the fuel system. When I say the fuel system, not just the engine. It can be an air leak in your primary fuel filter housing, the fittings. You know, put a wrench on it, put a screwdriver on it, check it periodically. Clear hose. I use this a lot to check the condition of the fuel system on the boat. Do I have an excessive amount of air in my fuel system? The engines, I don't care whether it's mechanically or electronically controlled, they do not like air in the fuel system. And if you suspect an issue with your fuel system, you can do some testing, pick up some clear hose. You can go to your local, fuel hose supply store, and get a piece of clear hose. Now, this is simply for a test. It can't be left in there long term. It's simply to do a test so you can get a visual on your fuel system. And if you do remove a fuel hose from a fitting, put a double-ended hose bar, plug that on your existing hose you took off, plug your clear hose onto the fitting that you remove your fuel hose, and get a good visual. You know, start the engine up and see what you got going on with your fuel system. If you got air, you can keep moving that clear hose upstream until you find the source of your air. It could potentially be your fuel pickup in your tank. So if you took that hose, it was at the engine, now you move it all the way to your fuel tank, the pickup coming out of the tank, and you've got the same amount of air there, then you know that's where my problem is. Here, it's not back at my engine, it's all the way up here at my fuel tank. So, like I say, you can do a little bit of investigating before, if you do end up calling a tech out to your boat, you can do a little bit of this ahead of time and be a little bit, have a better education on where your problem may be. Maybe the boat, maybe not the engine. Vacuum gauge. How many people have something that looks like this or a similar vacuum gauge? Okay, there's some people that have them. So some people that have them don't know how to use them or know how to read them or exactly what how they're used. So basically, what they tell you is you'll see 3 needles on it. Now this particular one has 3 needles, and this top needle here is connected to this bezel. And it's basically your set point. This is a set point needle. This needle here would be your actual reading, real-time reading when the engine's running. This needle here would be a highest reading used or read during the day. So I'm sorry. This one is actual. This is highest reading during the day. Where it's connected to the snob right here. This needle's connected to the snob. This is real time. So what they tell you is you start off with a known good fuel system, right? Your boat's performing properly, it's turning the correct RPMs. To the best of your knowledge, you've got new fuel filters. Your fuel system is 100% in your opinion. The boat's performing well. Okay, so you create a judgment standard. You pick an RPM, whether it's idle or 1,000 RPMs, 2,000 RPMs, whatever the case may be. Record that vacuum reading. Make a note of what it is. So So say your vacuum reading is 2. The normal fuel system, the vacuum reading is 2. When that vacuum reading doubles, whatever that number is, if it goes to 4, it's time to change your filters. If that vacuum reading goes lower for some reason, gee, it used to be my normal vacuum reading was 2 or 3, and now it's 1 or it's a half. If your gauge doesn't have a problem, if your gauge is accurate and there's not a problem with the gauge, then that's telling you, hey, maybe I've got an air leak somewhere. Maybe my restriction is less. I've got an air leak somewhere, and hey, my engine's not running so good either. So that's where that clear hose comes in. You can find where that air leak may be coming from and fix that problem. So if that reading doubles, whatever that number is, and it's boat specific, so there's no one number for any 2 boats. That's kind of the short version of how you use that gauge. So this needle that's connected to this bezel can be your set point. So when this red needle lines up with that red needle, it's time to change your filters. And then you reset it using this knob right here and set it back after you change your filters, and it goes back to normal vacuum. Leading cause of engine cylinder wear, shortened longevity. Propping, we talked about it earlier. The engine needs to be able to reach its rated RPM. I don't care if it's an outboard motor or whatever the case. It's got to be able to reach rated or above. At the rated RPM on an electronically controlled engine, you have the luxury of reading the load, the percentage of load. So typically, Myanmar says no more than 95% load at the rated RPM, not the continuous rating, but the max rating. So you have a way to judge that on an electronic engine. It's a lot easier to judge. And like I say, it's the responsibility of the owner, not the boat builder, to make sure you have the correct prop on the boat for your operating conditions, how you operate the boat and the way you load the boat. A little bit about props. Pitch is the speed, the diameter is the efficiency, whether you've got 2 blades, 3 blades, 4 blades. It affects the running angle of the boat, it affects the efficiency. So pitch is the speed, and diameter is the efficiency, where the number of the blades is the efficiency. Here's how you tell. Anybody want to take a picture of it or anything? This is just a formula for figuring out the efficiency of your propeller. If you're wondering about the efficiency of it, and that's going to change if your running gear and prop is not clean, obviously. But that is a formula that you use to determine the efficiency of your prop. Obviously, it's not going to be 100% efficient. Typically, somewhere in the 75% range. Causes of black smoke. Some more we talked about here, clogged air filter. Clogged air filter give poor starting characteristics, excessive fuel consumption, excessive oil consumption, and low power output on the clogged air filter. Black smoke also. How you take air temperature can do that. If you're over 20 degrees above ambient temperature, warm injection nozzles can also cause black smoke and piston damage, cylinder piston damage. Causes of white smoke, too much oil in the sump, large oil consumption. Improper valve clearances can give poor starting characteristics, excessive breather blow-by, and decreased power output. That's why you want to have a technician do it. Don't only attempt that yourself.